Alright, so we're back this week. We're starting in on logic. This is something that's probably new to you, if not cool. If it is, don't worry. We're going to do a brief overview and intro, and we're going to practice it this week. Alright, so I'm actually going to split up the logic into two videos. The first one, we're going to do conjectures and counterexamples, so that's going to be part 1. And then the second video is going to be part 2. It's going to cover conditional statements, inverse, and converse. So the first thing we are going to start with is conjectures. And first off, what a conjecture is a statement that might be true. We don't know 100% if it's true, but there's a possibility of it being true. And if you're having trouble thinking of what a conjecture is, kind of think of it along the lines of an educated guess. Alright, so we're now going to go into some examples. I'm going to show you two of them, two different types that you're going to see here in geometry with us. Now the first example I'm giving you is that all shapes have two sides. Now if you know whether or not that's true, that's okay, that's a different story. But the conjecture here I'm making is that all shapes have two sides. And the second conjecture or statement I'm making is that if a number is a multiple of 7, then it is even. Now you're probably thinking about those statements and you're like, oh, I don't really know. But we're going to get into the next part, which is counterexamples, and it's kind of going to make a little bit more sense. So what a counterexample is, it's a specific example that makes a conjecture false. So those statements I made earlier, if you thought about something that like, oh, I know something that makes that false, that would be a counterexample. So for your counterexample examples, we're going to use those same conjectures we used. So the first one is that all shapes have two sides. And if you know your shapes, if you know anything of that sort, you know that's not true. Now, when you were thinking and you're like, wait, I know a shape that doesn't have two sides, that would be your counterexample. So your counterexample would actually be that shape you were thinking of. So in my mind, the first thing that comes to my head is a square because it has 4 sides. So for the conjecture, all shapes have two sides, a counterexample would be a square. We do not have to have the same counterexample though. Someone could have said a rectangle, a triangle, any other shape that does not have two sides, which there really aren't any, would be a counterexample. So you don't have to match with your partner, you don't have to match my counterexample, it just needs to prove the conjecture false. Now that second conjecture I gave you said, if a number is a multiple of 7, then it is even. So then of course your counterexample would be any multiple of 7 that is not even, that is an odd number. So when I think about 7, the first multiple I think about is either 7 times 1, which is 7, or another one could be 7 times 3, which equals 21. And since 21 is an odd number, 7 times 3, or 21, is a counterexample for this conjecture. So I do have two that I'm going to have you try on your own. The first one, the conjecture is all multiples of 11 are odd. So I'm asking you to give a counterexample or identify a counterexample for this conjecture. So the second one I want you to try is, the conjecture is if a number is multiplied by 5, then the product is even. So that is all for this first video. Today is just watching the 2 ed puzzles. There's not a separate assignment. You will get a scavenger hunt tomorrow. So make sure you do understand both parts of logic before tomorrow.